say hi, Nupur. Is it okay? Abhi, एक second, let me check. हाँ एक हेलो
हाँ बोलना.
प्रियंका ask others as well to join.
या या.
Okay, done. Sounds good. I'll confirm. Thank you. All right. What was I doing?
Good evening, ma'am. Am I
A
audible?
very good evening. Yeah, you were audible. Actually, I was on mute.
All right, yeah. Ma'am, we'll wait for 5.
Everyone has heard about watching the but can you also believe this?
Hello, ma'am. Am I audible?
Yeah, you're audible.
Ma'am, can we start the session? It's okay.
Uh, yeah, sure.
All right, ma'am. Uh, Mindset is everything. Hello and a very good evening to all of you. My apologies for postponing this session. But RIT is hello. I am Akanksha Matpati, chairperson at RIT ACM Women's Chapter, and I'm your host for the day, along with my co-host Priyanka Shindis, technical chief at RIT ACM. RIT ACM Women's Chapter is a part of internationally recognized organization Association for Computing Machinery and is now a new beginning for all the ages of women in tech, supporting and celebrating all women with the motivation and helpful resources. RIT ACM W in our college was set into action on 9 February 2023 and is going headstrong. As for our guest speaker, our distinguished speaker for the day is Assistant Professor at Chitkara University, Neha Sharma, ma'am. She's instrumental in integrated teaching, being the founder secretary of Society for Data Science. She's also a senior and executive board member of IEEE Pune section. So today's expert speaker will be conducted by distinguished speaker Dr. Neha Sharma, ma'am. I hand it over to you, ma'am.
Thank you so much, Ms. Akanksha, for the kind gesture. And I would really would like to thank RAIT, the entire team of RAIT for providing this opportunity and for listening to me, right? So without wasting much of your time, let's just start with the unchaining the blockchain, right? Let me just share my screen. Okay. Myself, Dr. Neha Sharma, and I'm currently working as assistant professor in Chitkara University, Punjab campus. Let's just begin with unchaining the blockchain. Now, just to start with, what exactly blockchain is. All of us has heard about blockchain and Bitcoin, right? Now, Bitcoin was the first use case of blockchain, which actually introduced us to blockchain. Now, this Bitcoin, it came in the year 2009 by an unknown person, Satoshi Nakamoto, right? So, currently, blockchain has grown a lot apart from Bitcoin, and there are multiple organizations which are using blockchain in order to tackle the problems, right? For providing the different solutions. So, what exactly the blockchain is? It is again not a cryptocurrency, right? Cryptocurrency is the another use case for blockchain. So there are many other use cases of blockchain as well. It can be used under supply chain, trade agreements, letter of credit, or even the mathematical calculators. That can be built using the blockchain. So there are primarily these three things which are associated with blockchain. One is the technology that permits the transactions to be recorded permanently. Now, recorded permanently means that nobody can modify this data, or nobody can delete it, right? So this one is a primary characteristic of blockchain. Then is every data shared on blockchain is cryptographically secured in some chronological order. So every data is connected to every other data. Now, blockchain, it removes these central parties and intermediaries, and it creates a trust through the cryptography by just working on blockchain. Let us look at the current banking system, right? Consider this figure. You'll see that there are two users. The first user is paying some money to the second user, right? First user is he's transferring $100 to the second user, and we have a trusted third party in between, which is acting as a bank that deducts certain amount of money, which is say $2, and then those $98 they are transferred to the second person. Now, problem with the system is that there is some fees which is associated with this, and this is actually a heavy fees. Right here we are just considering $100. Let's say if it is $1 million or maybe more than that, then banking fees would be very much high, right? So The another reason can be that transfer of money also takes time. So there is a process which is included for large transaction. An important point is that we are trusting a third party to do our transactions, and we are ensuring a security from that trusted third party. The problem with current system is account hacking, right? We have seen a lot of cases where accounts are being hacked and money is being transferred. So there are different kinds of cyber attacks which are executed to transfer the money from one account to another account. Apart from account hackings, we have internet frauds, right, where people do some gullible activities and there are fraud peoples, and there are many victims which lose money. Then we have certain transaction costs which are usually high, right? Then is the transaction time is also high due to the intermediaries. Then is the dependencies on the banks, we really have a high dependency on the bank, right? Consider an example where, say for example, two teams are playing football, right? Now see, there is a referee who takes the decision. Now both the parties trust that referee. What if the referee is partial to one team? So that is what is the problem is we have in our current system. Now let us talk about the banking system using blockchain. Consider this figure, right? Here, instead of using one single person holding the data, we have different nodes organized here, right? So there is node 2, there is node 3, right? Node means computer systems, right? Node 1 this is, say, node 2, node 3, 4, 5, 6, right? So node means computer systems which are holding any user. So all these computers, they are connected to each other, right? Let us say, right, so there are three users, Alice, Bob and Eve, right? Now let's say Alice wants to open up a fixed deposit, or Eve wants to inspect her insurance document, or maybe Bob wants to deposit money. Then these transactions will be shared with all these computers which are connected to each other, right? Now major benefit of using such a solution is that if somebody has tries to modify this, right, he won't be able to modify. uh, Moreover, we are completely removing the central trusted parties. We are removing the intermediaries. What we are doing is that we are trusting the entire system itself. It could be a behavior where we can see the 10 computers which are connected together, or maybe from 10 computers, if 6 computers agree that the data which is being shared is correct, then we can say that data has not been altered. So this is a new blockchain system. Here you can see that the central parties have been removed, intermediaries have been removed. The blockchain is based on cryptography, so account hacking is also difficult, right? So even for the frauds, through blockchain we can track almost everything. Now the next question is how this blockchain solves the current problem. The point is that blockchain, it is based on cryptography. So every data is encrypted and then it is uploaded on the top of blockchain. Second point is that the different kinds of blockchain projects have different kind of protocols, and mostly it is present that the data is encrypted and then it is uploaded on the top of blockchain. So again, we have removed the central party, right? We have multiple machines, uh, because we now these multiple machines, they are connected to each other. And let us take an example. Suppose I am using our traditional systems to transfer $1 million, right? Then the fees is going to be very high, but if I'm doing it through the blockchain, then comparatively the fees is going to be low, right? Finally, the removal of central parties, which by which we are ensuring that system is trusted in itself, right? So we are not dependent on any third party to help us do the different scenarios, right? We are only trusting over our system itself. Now these are the two different architectures, one for the database and another one for the blockchain, right? So and in this database architecture, we have a central point where the attacker could attack and hamper the whole system, because we have this central point where the data is stored, and each client is accessing the same data through that central point. So this is a typical database architecture, right, which is stored at the central point, and each client is just accessing the data from that database. Now, see the architecture of blockchain. Here you'll notice that we have different nodes connected to each other, and these nodes are, nothing but computers which are connected to each other, and each computer has the same database. So it is, it is not, it's not like we have a central repository. We have the whole data is being stored, and each computer has its own set of database which it has maintained, and this database is synchronized within the whole process. So if some new data is entered by any of the node, then each node will update the database which is stored with them. So this is how the the architecture of blockchain is different from the architecture of traditional database. There are certain points of distinction between the blockchain and our traditional database. If I talk about authority, right, so the blockchain, it is decentralized, and the database, it is centralized. If we talk about the architecture, the blockchain's architecture is distributed, however the databases, it works on client server architecture. So the talking about the third point, that can be the data handling. So in blockchain, only the data handling is done through read and write operations. However, in database, we use CRUD operations, which is create, read, update, delete, right? Then is integrity. So in case of blockchain architecture, nobody can modify the data. However, in databases, alterations are allowed. So if we talk about transparencies, the transparencies in blockchain architectures are inbuilt. However, in databases, it is not transparent. Okay. Then is the working of blockchain. Now consider the five people in one room who decide to create their own currency. Now they need to know the flow of funds, right? They appointed, for that they appointed one person, right? For example, Bill is tracking the flow of funds, right? So whenever any transaction occurs, right, Bill is noting down the transaction, right, within his notebook. Now, so if Rob sends some money to Mike, it is noted in the notebook. If Mike sends some money to the Tom, again it is noted inside the notebook, right? So if Andy sends some money to the Bill, it is noted into the notebook. Now, in this window, there are two scenarios where this situation will not work, right? The first one is, we have created a trusted central party who is noting all the transactions. This trusted central party might be corrupt, right? The second scenario is the other four who are present: Rob, Mike, Tom, and Andy, right? They, any one of them can be attacker who wants to hack the system and modify the transaction within the system, right? So what if the central party, Bill, is an attacker and wants to change the transaction as the control authority? He's the controlling authority, so Bill easily can change the transactions, right? Rob, Mike, Tom, and Andy, they, if they realize that this is not good solution, so they decide, what they decide to share this notebook rather than to have Bill as a central repository. They share this notebook with everyone. So now everyone will note down the transaction, right? This is the first scenario. Let me just share. I'll explain it with some. Let us say, um, the first scenario is that Bill is the party to make the transactions, right? To make the transactions. Transactions secure and okay, to make the transactions secure, and let us say Rob is attacker, right? And who wants to benefit from the system. Now let us say the transactions, let's do the transactions one by one. Let's say the Andy sends one coin to Bill, right? Then is, let's say, Bill sends 5 coins to Tom, right? The third transaction is, let's say, Rob sends 2 coins to Bill, right? So these are the 3 transactions. Now, Rob wants to alter the transaction, right? So what he does is, say these were the transactions, right? Now Rob wants to alter this to 1 coin to Bill, right? Now Bill intercepted intercepted it, and he saw that something is not correct, as he had there's some variations into the data. So what Bill did was, right, he just changed his way of doing the transactions. He just added this to this, right? Something like this. He made changes like this so that no transactions could be altered, right? So he has added the, that's Andy sends 1 coin to Bill. Andy sends 1 coin to Bill plus sends 5 coins to Tom. Now Andy sends 1 coin to Bill plus Bill sends 5 coins to Tom, and Rob sends 2 coins to Tom. Now Rob, again, he modifies the entire transactions, right? When he sees that nobody is watching him, so he just modifies this transaction to, again, 1 coin to Bill. Right. Now, Bill was again not satisfied with this solution which he came up, right? So then he made use of hash function. Now, what is hash function? Hash function is one-way function which converts the variable length of data into fixed length. For example, we have SHA 256. Now, whatever the input is, if it is 1 byte, 1 bit, 100 bytes, the output is always going to be 256, right? So now Bill adds hash. So he writes here, this is equal to SHA 256 of and he sends 1 coin to Bill, right? Hash of this. Now he just changes the transaction to this way, right? Then is to see, right? And he changes here as well, right? And he adds the hash 256. I'm just taking this as an example, right? SHA of the third transaction. Now, Bob, let us say Bob modifies all the hashes which were done by Bill, right? Again, he has changed all the hashes. Attacker, right? He's an attacker, so he can change the hashes and again change the values to this. Now, Bill was again not satisfied with this, right? So then finally, Bill started adding random numbers to the hash of the uh, transaction, right? So let us say this was Andy sends one coin to Bill, and let us say there was some random number added to it and then hash of it, right? Same way he did for say, now let us say it is some alphanumeric number, right? So I'm just adding any alphanumeric number to the SHA 256 to the Bill sends to the Tom, and then again adding some random number, and it will lead to, this will lead to some other alphanumeric number, and then this alphanumeric number will be uh, you know added up here and plus some random number, right? Now this has a raised problem for the Rob, right? Because Rob does not know what this random number is, right? So this is the how blockchain works in a very similar concept like this, right? Okay. Then is the transactions. Now, what are transactions? Transactions are the records of data in some chronological order, right? They are stored in Merkle tree inside a block, right? The transactions, when they are submitted, they are picked up by the blockchain network, and then it is inserted into the pool of unconfirmed transactions, right? The transaction pool, it is a collection of all the transactions on that network that have not been confirmed yet, right? So the miners on the network, they just select the transactions from this pool and then they add them to their block. Now, transactions, they also contain certain metadata and information which can be utilized to store data over the blockchain. Then is blocks, right? A block is a container data structure which contain a set of confirmed transactions. Now, block could contain different information, and a chain of these blocks, they evolve a blockchain as long as it links one to the other. The blocks are stored onto the hard drives of many miners, and they're spread across the globe from on a peer-to-peer network. So if we talk about a Bitcoin algorithm, in that also a block is created every 10 minutes, and all the transactions that are happening over the network within 10 minutes of interval, they are actually crunched into that block, and then they are just added up to the chain. So all the blocks in the blockchain are composed of a header, the identifier, and uh, and a long list of transactions. So right, so you have block headers, you have block identifiers, and you have Merkle trees. Now, Merkle tree is consider this the four transactions: transaction A, transaction B, transaction C, and transaction D, right? We have joined transaction A and B, taken the hash of A and B, we've taken the hash of C and D, and then we have just joined the hash of A and B to hash AB, and joined the hash of C and D to hash CD, right? And then uh, it moves up to this root hash, which is also known as Merkle hash, right? Which we put up onto the block, right? Now, so within this blockchain Merkle tree, right, works in the same fashion, right? Here the different transactions, transaction 1, 2, 3, and 4, the hash of these are just joined together within the block, right? Yeah. Then is the consensus mechanisms. Now the consensus mechanism is, as we all know, the blockchains, they are the decentralized systems that contains the different participants, which who acts depending upon the incentives which they receive and the information which is actually available to them. Now when this new transaction, whatever happens, when it is broadcasted onto the networks, the nodes which are connected onto the network, they have the option, right? Either they can include that transaction and copy to their notebook, or they can just ignore it. So when majority of the nodes, they you know on the network, they just vote up to one single state, then we say that consensus is achieved, right? Then we have proof of work. Proof of work is, it is a consensus algorithm, right, where miners, they compete to solve a difficult mathematical problems which are actually based on cryptographic hash algorithms, right? So some of the problems like hash function, how to find the input, you know knowing about the output. Then is the integer factorization, how to present a number as a multiplication of 20 other, multiplication of two other numbers, right? Then is, here in this proof of work, miners, they receive a reward when they solve the complex mathematical problem, right? For example, bitcoin miners, they receive, for example, 12 bitcoins for solving a puzzle. Or miners, they can also receive transaction fees in addition to the rewards, right? Then we have proof of stake. Now this proof of work algorithm, it rewards the miners who solves the complex mathematical problems, right, with the end goal of validating the transactions and then creating the new blocks. However, if we talk about this proof of stake, on the other hand, right, the creators of this new blocks, they are chosen in some deterministic way, depending upon the the stake of the blockchain, right? So here no block is rewarded. All the digital currencies, they are created at the start of the chain, and their number never changes, right? Miners only take the transaction fees. Okay. Then we have the final mechanism of the blockchain transaction, how it actually happens, right? The user, he creates a transaction from their wallet, attempting to send a currency or maybe data to someone else, right? Then that transaction, it is put across a pool of unconfirmed transactions, right? This pool is a collection of unconfirmed transactions which are waiting to be processed by the miners. Then the miners on the blockchain, they just select the transactions from these pools and form them into a block. A block is collection of transactions with some extra metadata, right? Every miner, they create their own block, right? Multiple miners can put in the same transactions in their block. Then is, once the block is created, miners generate a block signature, right? So this signature is created by solving the complex mathematical problems. Every block has a different mathematical problem as per their transaction. Now the miner that finds a target signature for this block, first it broadcasts that block and these signatures to all other miners. Then finally all the miners, they verify the signature. If it is valid, the other miners will confirm its validity and agree that block can be added to the blockchain, right? This entire process is also termed as consensus, right? Enough of theory about blockchain transaction. Probably you would be able to better understand it with the tool, the online tool, right? uh, let me just show you the okay, right. This is an online simulator tool of the blockchain, right? Let us see whatever theoretically I have told you what blockchain is. I'm just going to give you a practical demo of that, right? Uh, the hash, right? We talked about it. Hash, it looks like a random number, right? And essentially, it is actually what it is. It is a fingerprint of some digital data, right? Whatever I type in into this box, the data box, let me type my name, Neha, right? Now, this, you might have seen the hash has changed, right? As I type my name, right? So, uh, you know, if I type a single letter, or I type on and on and on, right? This, it has a fixed length of data, right? If it is SHA 256 is used, then this will be 256, right? So, if, again, if nothing is in there, right? Again, we have some hash value. So we have it, it doesn't matter what amount of data we have. It is in bits, it's in bytes, it's in gigabytes. Now, the data section, which I've seen previously, it is broken into three sections. One is block, the second one is nonce, the third one is data, right? Now, block is a kind of number one, right? Nonce is just another number. Will go into what that is in a second, right? Then just some more data, right? However, the hash of this, you can see it begins with